Hello everyone, myself Dr. Santamayu Kundu. I welcome you all to this lecture of soft computing techniques. This is the fourth lecture of module 11. So last few classes we are solving problems of rule generations. In this class we'll try to understand the fuzzy wrap set. So wrap sets and fuzzy sets are two different but complementary concepts that provide effective mathematical tools for handling imperfect information. Their hybrid form, namely fuzzy wrap sets, are very useful in dealing with real-world data that involve vagueness and indecibility, making them particularly suitable for various applications such as data mining, machine learning, and decision making under uncertainty. Fuzzy sets and wrap sets address two important and mutually orthogonal characteristics of imperfect data and knowledge. While the former allow the objects belong to a set or relations to a given degree, the latter provide approximations of concepts in the presence of incomplete information. These two paradigms, through distinct, can complement each other effectively in managing uncertainty and imprecision. Fuzzy sets are particularly useful in situations where memberships to a set is not binary but rather expressed in a degree of memberships, which makes them well suited for handling gradual vagueness in real world data. On the other hand, wrap set excels in dealing with indiscernibility and imprecision, offering approximations of concepts when complete information is not available. So fuzzy sets deals with membership functions, union, intersection, and many more definitions. We have learned all these things. Wrap sets also deals with upper approximations, lower approximations, degree of dependency, etc. Here in wrap set, you know the positive region of the decision attribute Q with respect to the attribute A is the union of all lower approximations, and the degree of dependency gamma equal to the cardinal number of the positive region by total number of objects. So in fuzzy wrap sets, we need to find the membership value of each object. So that is the membership value mu positive region x pq, that is equal to the maximum value of x belongs to the partition q, that is u by u, u equivalence classes of decision attribute, and this is the membership functions of all lower approximations. So where mu px can be written as the maximum value of, that is supremum f belongs to u by p, then minimum value of mu fi x, infimum, that is minimum value of maximum 1 minus fi y, and mu x y. So that is the decision attribute. So first of all, we will try to find the maximum of 1 minus fi y mu x y. So that is step 1. Step 2 will find the infimum value, that is the minimum of all these values. Minimum of all these values. Minimum of values obtained in step 1. Then we'll find the minimum of mu fi x and this value. Then ultimately we'll find the maximum of f. F is the fuzzy set, so that u by v belongs to the different membership values of that. So we'll calculate these things, we'll understand. Now whenever we got these things, we will try to find the degree of dependency. So here is the summation of that value by total number of objects. So here we are giving one, so here we are dealing with one question. So you can write in table 1, that is basically the wrap set. There is no fuzzy here. So day 1, weather is 32, rain is 3, traffic jam is 7.5. The person will not go to the zoo. So there is no. Similarly for day 2, weather is 33 degree temperature, rain unit is 4.5, traffic jam distance something 4.5, and no. So these are the table. So this you can say that is the wrap set. So you can find that the gamma, I mean that the degree of dependency of the attribute go to the choose with respect to weather or rain or whatever traffic jam, you can find these things. Now we are introducing fuzzy sets here. So membership function of the attribute weather, so that is some temperature. When x is less than 25, so you can there are three membership value. One is hot, mild, and cool. So when temperature is less than 25, it is not hot. When temperature is belongs to 25 to 35, that membership value of the hot is x by 10 minus 2.5. For greater than 35, that is 1. So now for the first row, if you see the first row, the temperature is 32. So here the membership value will be, it belongs to this class. So that is mu hot 32 equal to 32 by 10 minus 2.5. So 3.2 minus 2.5, 0.7. Similarly, the membership value of mu mild x is 0 for x less than 5. For 5 to 25, it is x by 15 minus 1 by 3. For 20 to 30, it is 1. For 30 to 35, it is minus x by 1.5 plus 7. You can write 0 if it is greater than 35, like that. So here you can find the value here, that x equal to 32. So put the 32 here. So we'll get minus 32 by 5 plus 7. So minus 6.4 plus 7, 0.6. So mu mild 32 is 0.6. Similarly, for the membership value of the cool, so mu cool x equal to 1 if x less than 0, that is equal to 1 minus x by 15 if it is 0 to 15, and this is 0 if x greater than 15. So mu cool 32 is 0. So now initially we have weather, temperature was 32. Now we define three fuzzy sets. You can write it hot, you can write it mild, you can write it cool. So the same value is 0.7, 0.6 and 0. Similarly, the membership function for attribute rain. So there are two set, one is strong, one is weak. So now if x less than 3, 0, if it is 3 to 8, it is x by 5 minus 0.6. If it is greater than 8, then it is 1. Similarly, weak x is 1 x less than 3, 2.5 minus x by 2, can 0 to 5, and 0 for x greater than 5. So here given is 3, so put the value 3 here, so you will get it 0. Put the value 3 here, you will get 1. So that is the mu weak x. Similarly, for the traffic jam, the distance is less than 3 kilometer. You can write the short. If it is 5, you can write it is long, like that. So that is x less than 3. So that is 1. 3 to 9, 1.5 minus x by 6, greater than 9, 0. X less than 5 for long, 0. For 5 to 15, it is x by 10 minus 0.5. For greater than 15, it is 1. So here the x equal to 7.5. So mu short x equal to 1.5 minus 7.5 by 6 in this value. So it is 1.5 minus 1.25, that is 0.25. Similarly, for x is 7.5 plus here, so it is 7.5 by 10 minus 0.5. So that is 0.75 minus 0.5, so 0.25. So in this way, this table is converted to this is the rough set. Now it is converted to the fuzzy rough sets. So now it is the fuzzy rough set. So we can write it like a table 2. It is now table 2. This is. So similarly, for every value is converted. Now here for the decision, that is, if it is for no, if you see the table, so there are no for 1, 2, 6, 8 and 40. So this is no for 1, 2, 6, 8, 40. So the A means no here and B means for yes. So these values are for yes. So by using fuzzy set, we set in weather, A, write A equal to weather, B equal to rain, C equal to traffic jam, Q equal to D. The following equivalence classes are obtained. So U by A means hot, mild, cool, U by B strong, weak, U by C is long, short, and U by Q is AB, where A represents no, A represents no and B represents yes. So yes is these things. So now we need to use the formula. So for no, first we calculate the for no. For no, that is for 1, 2, 6, 8, 14. So for maximum of 1 minus mu hot 1 and mu x1. So you have calculate the mu hot 1 for attribute 1. So we need to calculate the value of hot. So hot, see here hot is 0.7, and so here you can write the value for mu. So find the maximum, and the formula is that first you find the maximum, then you take overall minimum, then you find again the minimum of these things. So first is that maximum of 1 minus mu hot 1, and this come from the decisions mu x1. So we are calculating for no. So no for 1, this is value of a is 1 here. So you can write maximum of 1 minus 0.7, and that is 1. So maximum of 0.3 and 1, which is maximum value is 1. Similarly, maximum value of 1 minus mu hot 2. So you can go for mu hot 2, that is 0.8. So 1 is 0.2, and the value is again the value is 1 here. So it is 0.2. Now 1 maximum is 1. Now 1 minus mu hot 3. So go for 3, that is 0.5. So it is 1 minus that also 0.5. So here mu x is, so the value is no. For the value of a it is 0. So it is 0.5. So similarly we need to find the all 14 value. So we have calculated value of all 14 here. So now the overall minimum, we need to find the infimum of all these things. So first you find the maximum for all this. Now we need to find the infimum, means the minimum value. So minimum value, if you check, the value is 0.3. So minimum value is 0.3 here, that is the minimum value. So that you can write the infimum of maximum of 1 minus mu hot y, and that this is for the no. So that is 0.3. So now our next aim is that we need to find the minimum of mu hot x 0.3. So mu hot x, so that is for first one is that minimum of 0.7, 0.3. So minimum value will get 0.3. So that will be the for first one. So we have calculated all the value. For 1 it is 0.73. For 2 it is 0.8, the value of mu hot 2. So 3, then mu hot 3, 0.5, 0.3. So mu hot 4. So check the value of mu hot 4. So mu hot 4, the value is 0 here. So that is 0, and the value is 0.3. So minimum is 0. So in this way we have calculated all the values here. So all minimum values. So now we have calculated the value of for the attribute for no, for hot. Similarly, we need to find the other weather attribute, that is for mild and that is for cool. So again we need to find the value for yes, the value for hot, mild and cool. So let's check this. So mild, so 1 minus mu mild 1, so that is 0.4. So the maximum is 1. Here also 1 mild 2. So check the value of mu mild 2. So mu mild 2, the value is here 0.4. So it is 0.4, and so 1 minus is 0.61. So the maximum is 1. So similarly, if you check these things, all value calculated. So we have checked the value that the minimum, that infimum, that the value infimum of maximum 1 minus mu mild y, mu x y. This value, if we check here, the value is 0 here. So if the value is 0, then definitely the minimum value of mu mild x 0, so that will be 0. So for all attribute will get 0. Similarly for cool also will get 0. So here we need to find the value of supremum f belongs to u by p, that is hot, mild and cool. So for the one attribute value is 0.3, and then for 8 also 0, for 2 0.3, for 9 0, for 3 0.3, for 10 0. So that is the value for the attribute no. Similarly, we need to find the same way we need to find for the attribute yes. So for yes equivalence classes for x is 3, 4, 5, 7, 9, 10, 11, 12, 14, and we need to find the same way. First to find maximum, then infimum, then again minimum, then we need to find the overall maximum for that. That is first hot, then mild, then cool. So let's check it. So 1 minus mu hot 1 mu x3, so that is maximum of 0.3 and 0, so that is 0.3. 1 minus mu hot 2 maximum 0.2, so that value 0, that is 0.2, 0.2. 1 minus mu hot 3 mu x3, that is 0.5 and 1. 1 minus mu hot 4 x 0.4, so that is also 1. So in this way you calculate the value. So here the minimum value is here 0.2. So infimum value is 0.2. So minimum of mu hot, and so this value is 0.2. So we need to find the minimum of mu hot x and 0.2. So for this one is 0.7, 0.2. So minimum is 0.2. For mu hot to 0.2, that is minimum of 0.8 and 0.2. For minimum mu hot 3, 0.2 is minimum of 0.5, 0.2. So that is 0.2. And similarly, you test all as 0. So similarly for attribute mild and cold, you will get this value is 0. So now we need to find the value of uh, lower approximations for the decent attribute y, that is yes are for 2 3 4. So this value will be the supremum of that, so that is supremum of f belongs to u by p, that basically for hot, mild and cool. So first is 0.2, then for hot you get 0.2, for mild and cool all are 0, so the 0.2. Similarly for the 8 you will get 0, that these two are 0. So we got these things 0, 0.2. Now for the positive reason we need to find the supremum of x belongs to u by q, then mu a bar a lower approximation of the x. That means we need to find for u by q belongs to yes or no. So first you calculate the value for no, then you calculate the value for yes. So that is uh, for 1. So mu positive region AQ1 is equal to the supremum of x belongs to u by q mu a bar x1. So that is supremum of lower and upper. So mu a approximation no, mu a approximations for yes. So for no we have calculated 0.3. So and for yes we have calculated 0.2. So the maximum value is 0.3. Similarly you can find the 8. So for 8 if you calculate, so the here 8 is 0, and for yes it is 0. For no you can check, the for no you can check for 8, that is also 0. So the value is 0. For 2 here it is 0.3, and then here the value is 0.2. So maximum is 0.3. So similarly we have calculated all the values 0.3. So that is also 0. All the values are there. Now next step is to determine the degree of dependence of q on a, that is the weather. So that is as follows. So that is degree of dependence of q on a. This is basically the degree of dependency of the of u by q with respect to the attribute a is the equal to summation of mu of positive region of of A q x by total number, so total is 14 is there, so this is 0.3 plus 0.3 plus 0.3, so this 0.3 come from this 0.3 is come from for 1, another for 2, for 3, 1 2 3 and 13, so 1 2 3 4 13, so that is 0.3 plus 0.3 plus 0.3, so you can write it like this is basically the 1.2 by 40. So in this class we have understood the degree of dependency of fuzzy graph set. So we have calculated the degree of dependency of the Q, that is the decision with respect to the attribute weather. So try to calculate the degree of dependency of Q on rain. Also find the degree of dependency of Q on traffic. So that is the questions. You try to solve these things. These are the references of today's class. Thank you.